Alright, welcome to part 2 of today's topic, which is the last part of our course, chapter 14, Sequences and Series. So let's look at this. It's not a handout, I changed it to a slide. This is the slide that I used last semester. I think the slide explains things a little bit better than the handout. So I got rid of the original handout and did the slide instead. Let's look at the agenda that we're going to cover today. So we're going to talk about introduction to sequences and series. And then we're also going to talk about two types of sequence and series. They are arithmetic sequence and series, geometric sequence and series. We're not going to talk about binomial expansion. If you're interested, please read the textbook. Let's start today's topic. First is introduction to sequences and series. You oftentimes see these kind of problems in like a puzzle problem. For example, name the next three terms for each list of numbers and also state the pattern. So I gave you 2 minutes. Pause this video, try to figure out the next three terms for each problem, and then also state what the pattern is to allow you to find the next three terms. Alright, hopefully you found your answer. Number 1. For number 1, the next three terms, if you look at it, it's probably very easy to see that the pattern is simply plus 3, right? You increase by 3. Therefore, the next three terms are 10, 13, and 16. The pattern is simply plus 3. Number 2. Number 2, it's also very easy to see the pattern, which is minus 4. Therefore, the next three terms will be negative 9, negative 13, and negative 17. Number 3. 1, 2, 4, 8, 16. As you can see, every number is twice as large as the previous one, so you just double the previous one. Therefore, the next three numbers, 32, 64, 128. And then we have, and by the way, the pattern is times 2. And then we have number 4, 81, 27, 931. The pattern is dividing by 3. So the next one will be 1 over 3, and then 1 over 9, and then 1 over 27. And by the way, you don't need to use decimals to represent. Fractions are perfectly fine. The next slide summarizes the main idea of chapter 14. We have two things, right? One is the sequences, the other one is the series. A lot of people got confused about these two things. They think that they're exactly the same, but they're not. Sequences are referring to a list of numbers that follow a specific pattern, like these 4 lists that we have right here. Each list follows a pattern, which was explained in the quotation mark right there. If you have a list of numbers that follows a specific pattern, then you could call that list of numbers a sequence. What is a series? Series is simply the sum of numbers. So you're adding, let's say, the first term all the way up to the 100th term in this particular sequence, then that gives you the series. Or instead of starting from the first term, you could starting from, let's say, the 10th term in your sequence, and then you add all the way to the 100th term. That will also be a series. So this is the main idea between sequences and series. Sequences, numbers that follow a pattern. Series, sum of numbers in your sequence. The notation that we're going to use for this chapter, these are the notations. Terms in a sequence, we're going to use A1, A2, A3, all the way up to A2 infinity, no matter how many terms you have, to represent the terms in a sequence. And over here, we have this A sub n. This is the general term of a sequence. We also call it the nth term because the subscript is n, so it's the nth term in a sequence. And as you can see, the n can be replaced by any whole number. You could do A1, you could do A2, A50, A100. So that's what the an is. It's the general term of the sequence. The sum of the first n terms in a sequence, so you simply add the first n terms. This is the notation, right? A1 plus A2 plus A3 all the way up to an. And the notation is basically the Sn right here, S sub n. That is the notation. This Greek letter sigma is the summation notation. It just represents that you're adding things. And the things that we're adding is a sub k, where k ranges from 1 all the way up to n, which is equivalent to saying that adding a1, a2, a3 all the way up to an. So here's a typo. This one should be n right here. Let's move on to the first type of sequence, which is the arithmetic sequence. Arithmetic sequence follows a pattern that indicates a common difference between any two adjacent terms. The difference could be positive, negative, or 0. The general term has this formula: an equals a1 plus n minus 1 times d. And the finite arithmetic series, meaning that you're adding a finite number of terms in an arithmetic sequence, is given by n times a1 plus an divided by 2. Let's look at one example and see how we can apply this formula to solve problems like this. So we'll try to keep both slides on the same screen so you can actually look at the formulas. For the sequence 3, 7, 11, 15, find the common difference d. The common difference d, the easiest way to find is simply calculate the difference between any two adjacent terms. If it's consistent, then it is an arithmetic sequence. Apparently over here we have common difference of 4, because 7 minus 3 is 4. Number 2, find the first term a1. This one should be super easy. First term is 3 because that's the first term in the sequence. Number 3, find the general term an. So this is the one that way you have to use the formula. An equals a1 plus n minus 1 times d. A1 is 3 plus n minus 1. Because we're doing general term, you're going to keep the n and then multiply by d. Our d is 4. If we simplify this expression, we will get 3 plus, and you have to distribute that 4, so 4n minus 4, which is the same as 4n minus 1. So that is the general term of the sequence, 4n minus 1. You could use this general term to find out any term in the sequence. You simply replace n with 1, 2, 3, 4, 5, 6, 7, 8, all the way up to whatever number you like. Number 4, use the general term to find the 50th term in the sequence. So as I just said before, we're going to replace n with 50 and plug it into the formula that we found. A sub 50 equals 4n. Now n becomes 50. So we replace n with 50. Oops. And then you complete the calculation. So we have 4 times 50 minus 1. That is 200 minus 1, which is 199. Finally, find the sum of the first 50 terms in the sequence. So this one you have to use the formula above for the finite arithmetic series. We are calculating S sub 50. According to the formula, it's n times a1 plus an over 2. Our n is 50 because we're adding 50 terms. And then our a1 is 3 plus an, which is a50, right? So let's actually do a50. A50, we just calculate that above, which is 199, and divided by 2. So this will be the expression to calculate the sum of the first 50 terms in this particular arithmetic sequence. If you calculate that, you should get 5050 for your sum of the first 50 terms in the sequence. Alright, now it's your turn. So I have this practice problem right here. The sequence is 55, 45, 35, 25, and dot dot dot. And you're going to complete all 5 of them just like what we did. Make sure you pause the video and work on your own. When you finish, check your answer with this video. Good luck. Alright, hopefully you actually did the problem, because this problem will be on your final exam. Number 1, find the common difference D. So if I subtract 45 by 55, I got negative 10. If I subtract 35 by 45, I also got negative 10. Therefore, in order to get the next term, all you need to do is subtract 10, which means that the difference between any two adjacent terms in the ascending order is negative 10. This is actually very important. If your number keeps decreasing, that means your common difference, assuming it's an arithmetic sequence, will be negative. Otherwise, it will be positive or 0. Number 2, find the first term A1. Super easy, which is 55. Number 3, find the general term. So an equals, and then use the formula a1 plus n times n minus 1 times d. And then you plug in the numbers. A1 is 55 plus n minus 1 times d, which is negative 10. And we're going to simplify this algebraic expression. 55, you distribute negative 10, that's negative 10n. And then negative 1 times negative 10, that's positive 10. Combine like terms, we obtain 65 minus 10n. So that is the general term for this particular sequence, 65 minus 10n. Next one, use the general term to find the 50th term in the sequence. So you're calculating a sub 50. We're going to use this formula, plug it in. 65 minus 10 times, now n is 50. If you compute this, you will get a negative number, in this case negative 435. So that is the 50th term in this particular sequence. As you can see, the numbers are decreasing, so you're expecting to get something negative for the 50th term in the sequence. Number 5, find the sum of the first 50 terms in the sequence. So very similar to before, we're going to apply the formula, which says that it's 50 times a1 plus a50 divided by 2. So I can cross out the 50 and the 2, right away, because they have a common factor of 2. So 50 becomes 25, 2 becomes 1. We have 25 times a1. a1 is 55. Let's use the red for substitution. 55 plus a50. a50 is negative 435. So negative, let's do plus negative 435. Let's put in grouping symbol. So this will be the expression. If you compute this, you're gonna get negative 9500. And that is the sum of the first 50 terms in this particular arithmetic sequence. If you could do these two problems with no problem, then that pretty much means you mastered the arithmetic sequence and series along with their formulas. Moving on to the last part of today's lecture, which is the geometric sequence and series. This is the other type of sequence that follows a different pattern. Instead of having a common difference, geometric sequence refers to terms that have a common ratio r. And the ratio right here could be greater than 1, less than 1, or equal to 1 in terms of the absolute values. So you could have a sequence that's increasing or decreasing, or in some cases alternating. That's also possible. The general term is an equals a1 times r raised to the power of n minus 1. And the finite geometric series has this formula for the sum of the first n terms, which is a little bit complicated. but try your best to remember this. As for the last one, the infinite geometric series, this one is often used in calculus. So if you are not going to do calculus for your next math class, you could forget about this one. We're not going to use this one. We will only use the first two formulas. Before you apply any of the formulas from this lecture, make sure you identify the sequence. Categorize it. Is this arithmetic sequence or a geometric sequence? Because the formulas are different. That's very important. So let's look at this example right here. It's a 4, 2, 1, 1/2, and dot dot dot. If you calculate the difference, they have different differences. But if you calculate the ratio, if I do 2 divided by 4, that's 1/2. If I do 1 divided by 2, that's also 1/2. If I do 1/2 divided by 1, that's again 1/2. So if you do quotient of any two adjacent terms and then you get the same answer, that means this is the geometric sequence. For geometric sequence, we have a common ratio. For this particular problem, the common ratio is 1/2, as I illustrated before. So it's basically 2 divided by 4, that is 1/2. First term A1. First term A1 is simply the first term in the sequence, which is 4. Find the general term. So we're going to use the formula right here to find out the general term. Try to put both of them together. AN equals A1 times R raised to the power of n minus 1. Let's plug it in. A1 is 4, R is 1/2 raised to the power of n minus 1. And that is already good enough, I would say. You could just keep it like that. That's a very good expression. If you really want to simplify, you can if you want. Number 4, use the general term to find the 50th term in the sequence. Write your answer in exponential form. Exponential form means that you don't have to actually get the actual value. You just need to write it as an exponential expression. That's all you need. So let's use the general term to write down the 50th term in the sequence. A50 equals, so we have A1. A1 is 4, so let's plug it in. Multiply by R. R is 1/2. Oh, actually we have the formula right there, right? We don't need that. So you simply do 4 times 1/2 and then replace n with 50. So this is 50 minus 1. And that is equal to 4 times 1/2 raised to the power of 49. This is the same thing as 2 squared times 2 to the negative 49. So I'm just using some of the exponential properties. Rewrite both of them as the same base, which is 2. And then I apply the product rule at the exponents. So it's equal to 2 raised to the power of negative 47. As you can see, I wrote my answer as an exponential form instead of the actual number, because if you do the actual number, it's going to be a very small number. Number 5, find the sum of the first 50 terms in the sequence. So this is talking about S sub 50. We have a pretty complicated formula. Let's apply the formula first. First is A1 multiplied by 1 minus R raised to the power of n, which is 50, divided by 1 minus R. Let's plug it in. A1 is 4 times 1 minus R is 1/2 raised to the power of 50 divided by 1 minus half. So for this one, if you do like that, it's already good enough. But if you simplify, you actually are able to simplify this. The denominator is basically 1/2. 4 divided by 1/2, that is 8. So it just becomes 8 times 1 minus, this is 2 to the power of negative 50. And I'm going to rewrite 8 as 2 to the third later. So you're going to distribute 8, and that will give you a minus 2 to the negative 47. So this is if you apply exponential rules, and then you will get your answer like this. And again, we didn't write down the actual number, we just used the exponential form to write your answer. So we can skip number 6 because we're not discussing number 6. And now it's your practice time. This is the last problem that we're going to discuss today. For this particular sequence, 2, negative 4, 8, negative 16, you're going to do what we just did except number 6. So get rid of number 6. You're going to finish number 1 to number 5. And make sure you pause the video and work on your own. When you complete, check your answer with the video. Good luck. Alright, hopefully you finished. So let's check your answer. Number 1, common ratio. Common ratio, the easiest way to do is you just use the second term divided by the first term. This is definitely a geometric sequence because if you perform the ratio of any two adjacent terms, you will always get the same number. In this case, it's negative 4 divided by 2, that's negative 2, and that is your common ratio. And notice that because our ratio is negative, the terms, they alternate in terms of the sign. So you have plus minus, plus minus, plus minus. Number 2, find the first term. Super easy. First term is 2. Number 3, find the general term an. So general term an for geometric sequence is a1 times r raised to the power of n minus 1. Let's plug it in. a1 is 2 times r, which is negative 2, raised to the power of n minus 1. So I'm just going to keep it like this for my general term. Number 4, use the general term to find the 50th term in the sequence. Write your answer in exponential form. So we're looking for a sub 50. We have a formula, you just plug it in. 2 times negative 2 raised to the power of 50 minus 1. That is the same thing as 2 times negative 2 raised to the power of 49. So here we're going to do a little trick for negative 2 raised to 49. Because the base is negative and our power is also an odd number, if you get rid of the grouping symbol, you're still going to have the negative sign. So it's basically the same as negative 2 to the 49. And then of course you multiply by the 2 in the front. Apply the product rule. You add the exponents, which is, there's an invisible one there. So it's negative 2 raised to the 50th. And that will be the 50th term in this particular geometric sequence. Finally, we do the most exciting part. Find the sum of the first 50 terms in the sequence. So this is S sub 50. Let's plug it into the formula. The formula is a1 times 1 minus r raised to the 50th divided by 1 minus r. a1 is 2 and multiplied by 1 minus r. r is negative 2 raised to the power of 50 divided by 1 minus r, so 1 minus negative 2. And again, we have that double negative in the denominator, so it becomes positive. Now let's simplify this. If you simplify this, the denominator is 3. As for the numerator, I can distribute the 2. But before I do that, I want to simplify the exponential part for the 50th power. Because the base is negative, but our power is even, so if you actually calculate, it's going to be a positive number. That's why I'm going to get rid of that negative sign inside. And then I'm going to distribute the 2 outside. If I distribute the 2 outside, I will get 2 minus 2 to the 51st divided by 3 for my answer. And that will be the sum of the first 50 terms in this particular sequence, which turns out to be a very negative number. So that pretty much concludes chapter 14 as well as the entire class. So we finished everything now. As for the homework For chapter 14, it's the last 2 pages right here. If you look at the OneNote, it's at the very bottom. You could print it out, or you could just copy the question to your notebook and write down your answers. These are basically same questions, very similar questions that we did in class. And good luck. Next time when we meet, it will be, I believe, May the 7th. Let's check out the course table. Yeah, May the 7th. So the next time we meet will be May the 7th, and then we will go over your exam 3 review session. And make sure you submit all the homework before its due date. I will see you next time. Thanks for watching.